So I want to start out by looking at this particular decimal, which is 6 and 725 thousandths. Now remember that our decimal place, which is here, separates our whole number, which is anything to the left of our decimal, and that's going to include, in this case, the ones place, but also any place bigger than the ones place, so the tens or the hundreds or the thousands. And it also includes our decimal numbers. So in our decimal numbers here, we have our first and biggest decimal place is the tenths. Then we have the hundredths. And remember, it's important to put that THS sound at the end. And then we have the thousandths. And it's okay to spit a little bit when you say that noise, the THS. So in this case, we have 6 and 725 thousandths. Now, one cool thing about decimals is that we can really easily multiply and divide decimals by tens, hundreds, and thousands. One way we can do that is if we want to multiply a decimal by 10, because every place value is 10 times bigger than the one before it, all we have to do is move the decimal once to the right. And that would be the same as multiplying by 10. If we want to multiply by 100, so we multiply by 10 there. If we want to multiply by 100, multiplying by 100 is the same as multiplying by 10 twice. So if I want to multiply by 100, all I have to do is move a decimal twice to the right, which is the same as multiplying by 100. And if I want to multiply a number by 1,000, that's the same as multiplying a number by 10 3 times, which is the same as multiplying by 1,000. Now, to get an idea of what this looks like, we'll look at an example. We'll take this number, 7 and 23 hundredths, and we'll see what it would look like to multiply it by 10, 100, and 1,000. So if we look at what we just learned, we say 7 and 23 hundredths times 10 would be the same as taking this decimal and moving it over once to the right, which would be 72 and 3/10, because we moved it over once. If we multiply by 100, that's the same thing as multiplying by 10 twice. If you take any number and multiply it by 10 twice, and you multiply it by 100 separately, you will get the same answer. So that's the same as moving the decimal, multiplying by 10 once, multiplying by 10 twice, 2 times. There I get 723. And in the third case, multiplying by 1,000 is the same as multiplying by 10 3 times. So I can just move the decimal over once, twice, 3 times, which would give me, and in this empty space, I can just add a 0, 7,200 maybe. 7,230. So we can easily multiply and divide by tens, hundreds, and thousands. Now, the nice thing is when you divide, it's just the opposite. So if I divided by 10, I would just move the decimal once to the left. If I divided by 100, that's like dividing by 10 twice. So I would move it twice to the left. And dividing by 1,000 would be like dividing by 10 3 times, which would be moving 3 times to the left. Now, the cool thing here is we can use this in any sort of multiplication problems when we start in division, when we start to work with decimals. So let me give you an example. Let's say I was going to multiply these two numbers together. 6 and 25 hundredths times 13. Now, the first thing I always like to do when I'm looking at any sort of computation is kind of get an estimate of what kind of answer I'm going to get. I notice I have 6 and 25 hundredths. That's less than 6.5 because remember 6 and 50 hundredths would be half. So I'm going to say that's about 6. So I'm doing 6 times 13. If you're not certain what 6 times 13 is, that's fine. I'm just going to do 6 times 12 just because I know really quickly off the top of my head what that is, which is 72. Now, I'm expecting that my estimate here is going to be a low estimate because I lowered both of those numbers. So I should get something a little bit bigger than 72. Now, when we go to multiply something like this, all I'm going to do is I'm going to take the decimals in my number and I'm going to increase them, make them whole numbers by multiplying by factors of 10. So 10, 100, 1,000. So in this case, I noticed that if I move the decimal over 2 times, I will get a whole number for this first number, which would be 625. Now, when I moved it over twice, I have multiplied by 10 twice, which is the same as multiplying by 100, which means I've actually made that number 100 times bigger. I've changed this problem. So I'm going to do 625 times 13. I'm not going to do anything to that second number because it's already a whole number. Now, the thing we need to recognize here is because I multiplied by 100 in the beginning of this problem, I am going to get an answer that is 100 times bigger than it should be. So I will make up for that by dividing by 100 in the end. Now at this point, all I'm going to do is I'm just going to multiply 625 times 13. So first I'll do 625 times 3. As I move to the tens, I'll put a 0 down in my ones place. Add these two partial products together. And I get 8,125. Now, you'll notice that's significantly bigger than the estimate that we originally thought. It's because I have multiplied this number by 100. It is 100 times bigger than it should be. So to make up for that, we're just going to do the opposite operation and divide by 100. And notice you don't see a decimal in this number. It's because it's a whole number. And every whole number is just at the end. And because we're dividing by 100, that's like dividing by 10 twice. We will move it back 2 times. And my final product here would be 81 and 25/100ths, which is pretty close to that estimate that we said. We said our estimate was going to be a little bit too low. Now, this same idea can work also in division. So, for example, if I were looking at a problem such as this, we could use this exact same strategy. 29 and 28/100ths divided by 4. When I am estimating here, I'm just thinking I always kind of think of it backwards. I think what times 4 would give me close to 29 and 28/100ths, and I'm going to say that would be about 7 times 4. 7 times 4 would give me that. So I'm expecting my answer then will be somewhere close to 7. So just like we did last time, I can take here, I can take this number. I can say, can I make it into a whole number? Sure. Move the decimal over 2 times. That would be 2,988. When I moved it over twice, that's multiplying by 10 twice. I made it 100 times bigger. So in this case, I am going to, just like I did before, I'm going to divide. And then when I get my final answer, because my answer is 100 times bigger, I'm going to divide by 100. So this strategy, this idea of multiplying by tens, hundreds, and thousands and dividing by tens, hundreds, and thousands can make multiplying and dividing decimals really super easy. The only other thing that you would need to know here is if I had another decimal as my second number or that I was multiplying by, it would just do the same thing. With that number, multiply as whole numbers, but then you would have to think a little more about what you did to those numbers to figure out what you're going to divide by in the end. So use this strategy for when you're multiplying and dividing with decimals, and I definitely think it's going to help you out.